I've got the operation.
Alright.
I think I've only got 10 minutes.
Mix here.
Links, yes. I think I've got.
Alright.
From Google.
So guys, tonight we'll get kicked on because it's already 8 o'clock, so we'll kick things on. So Nick, welcome to the club. Thanks very much for giving us your time to take us through these bits and pieces. As I promised, we'll make you internet famous, and he assures us that he's not a strong presenter, so we should heckle as much as possible as a form of encouragement. So over to you, Nick. Thanks very much.
Thank you very much. Good evening to all, and thanks for coming. You're a very brave bunch. I do need an assistant. There are a couple of slides with long sentences containing some difficult words, so instead of me reading, Tim will be kind enough to read. So if you see a lot of text, just to read aloud. I mean, everyone can see, but it just feels better. It gives me a little bit of time to recover. So, the title of this presentation, how much time do I have? How much do you...
3 hours?
No.
As long as you
20
want.
minutes, 25 minutes?
Stop at midnight.
As long as you want.
As long as you want. Normally they go from half an hour to an hour.
When you see a lot of empty chairs, it's a hint.
Yeah. Right, so the subject, the title is Getting on 630 meters and Having Some Serious Fun. Whether it's possible or not, well, hopefully this presentation will give us some answers to, well, we're already having fun because this is not working.
Did you put it in the microwave?
Yeah. Okay, sorry guys.
You want me to leave a barrel or something?
If you don't mind, yeah.
Come over here.
Maybe if you sit over there, assist me.
Go!
Okay, next slide, please.
Where's the header?
Just click on the screen and... Yep. There you go. Try the clicker now.
Okay. So next one, please. Yeah. This is not a lecture. My job here tonight, or a purpose why I'm here, is to excite you about 630 meters. It's definitely non-technical presentation. I come from a non-technical background. I'm a watchmaker by trade. So everything I know I learn from people like you. So if I make mistakes or struggle to express myself properly, that's because of you. Next one, please. I started my ham radio career at age of 13. You can tell I'm a foreigner. This is my call sign, YU7QDT, which is, back then it was Yugoslavia. And when I got into ham radio, I learned two things. There is a mode called CW and sideband, which was lower sideband because I was only allowed to operate on 80 meter sideband. And everything else that you can hear on air was teletype. For me and my friends, if there was a signal there, it was a noise, whatever it was teletype. So my view of what's going on the radio waves is like a view of cosmos, where you have a moon and sun and everything else is somewhere far, far away. It was beyond reach of, next one please. So somehow I discovered the magical word of teletype by looking at the signals. Hearing signal is one thing, but being able to see the signals is something completely different. And you see a very colorful stuff on this. This is a signal on obviously 3597. It looks fantastic. Next one, please. As another colorful signal. you see, there's not much that you can get out of this signal unless you are able to decode it. Again, for someone with very limited technical knowledge and very limited experience, it was something, you know, far, far away. Next one, please. Of course, you guys who are professional radio guys and look at the spectrum, you understand, you know. See, oh, this is another complex signal. Again, if you tune in by ear, you hear some noise, a little bit of beep, beep, beep there and there, but it really looks complex and it really is a very interesting signal.
Next.
Yep. There's another one. There's another one. Okay. So there's a lot of stuff out there that if you only CW operator or only a sideband operator, phone operator, you miss a lot of this stuff, right? Again, ability to see the band, not just to hear and listen, to tune, but to see the band. This is a perfect example of 40 meters spectrum and over the horizon radar, which nicely covers, you know, this section from about 6960 to 740, and there's another bit there. So again, if you don't know what's going on, if you're unable to see the band, see the spectrum, all you will hear is a noise, a pulsation, and that kind of stuff. But again, ability to see stuff is very powerful. And there are some other complex signals. For example, this one is WWVH. I'm sure you're all familiar with time signal that is transmitted from Hawaii. This one is on 15 megahertz. So if you tune your radio on 15, you will hear the voice, which announce time, universal time, and you also hear some bips, right? But those bips are all over the place, and they mean different things. You have your minute marker, you have your 100 hertz BCD time coded carrier. These are the audio tone somewhere, and voice. See, this is the voice bit. This is of course a snapshot, 5:30 over an hour almost. And you know that on 15 megahertz there are two signals, two time signals. One is transmitted from Hawaii, and the other one is transmitted from where? Colorado. And they're nicely offset. So this is one signal, and a little bit darker. This is the other signal, and the Hawaii signal is time is announced by a lady, and a lady speaker, and the Colorado signal is announced by male speaker. So if you hear the time, if it's male, it's from Colorado, and female from Hawaii, and so on and so on. So it's a simple signal. We tune in many times, but you know, ability to see what's going on is again. Next one, please. It's quite powerful. You see the call sign there? ZL1EE. This is another signal in a graphic mode. So again, if you tune in that signal on that frequency, you won't hear anything. Just maybe a little bit of beep beep sometimes. But you know, if you're able to see the spectrum, then you will, and decode it, you will see the signal. Next one, please. So 630 meters band is the band where you play with those signals, right? Where you play with the signals that you cannot hear, but you can, if you're properly set up, you will be able to decode them. And is that fun? Well, sometimes it is. What is the problem with 630 meters allocation? We got the 630 meters allocation last year. So Australian, if you have a full call sign, you're allowed to transmit on 630 meters. This is 472 to 479. It's a fairly limited bandwidth, limited power. We're allowed to run 5 watts radiated power. There's plenty of man-made noise, but there's also plenty to experiment with. And this is all easy if you live in a rural location. If you're on a farm, somewhere south coast, north coast, it's easy. Yeah, there's less noise. You have room to put up your antennas. But the problem is, you live in a city, on a small city block. Can you have fun really on 630 meters? Right now you are instinctively cautious because you know that quarter wave vertical for 20 meters is only 5 meters high. That's not a problem. You can set it up in your backyard on top of your house. Neighbors will not complain. It's all good, sweet and easy. And you can have a lot of fun. You can work a lot of strong signals. There is that pipeline opening on 20 meters, you know, in the late afternoon till sunset to Europe. Everyone is loud, no problem. 100 watts vertical, you will make plenty of contacts. 40 meters, 10 meters vertical, yeah? Still a lot of fun. You can work plenty of guys because there's a lot of well set up amateurs in US and in Europe. They have, you know, 3-4 element Yagis and they can hear you nicely and that's not a problem. Problem is if there's a pile up, you know, so more than 2-3 people calling, you'll be last in part. But 80 meters is really tricky. You need 20 meters vertical and there is simply no room in average backyard to put up 80 meters vertical. Even if you do, you will quickly realize that your radial system is not sufficient. You don't have room for radials. So you will have to put up with few short radials instead of, you know, larger radials. And immediately your antenna is not efficient like it was on 20 meters. People try to overcome this and compensate recompensate by running a lot of power, putting a lot of power into inefficient vertical works on 80 meters. If you run 3-4 kilowatts, you can have a decent pileup. Problem is you won't be able to hear guys calling you. But another way to compensate this is to tune in to remote receivers. So I'm here in Sydney tuning into receiver in Holland and I can hear all the Europeans loud and clear, they're calling me. It's cheating, but people do that a lot. So it's not fun. So 80 meters you can still have some fun. You know, if you want to cheat, you can have fun. 160 meters, you know, it's impossible. Has anyone put 160 meters quarter wave antenna in the backyard? You tried? No? No?
We've done it here once, but for a contest, but yeah.
Like L rather than a vertical, so it's changing a bit.
It's really a problem. Even if you can start with, you know, your 80 meters with huge loading coil. Again, problem with radials, it's inefficient. You want to hear a thing and people won't hear you. So that is really a problem. So why bother with 630 meters where quarter wave is 157 meters? It's crazy. You know this is wrong way. We're heading in the wrong direction. Next one, please. But there is one trick. There's one tricky thing. There's one beautiful thing about 630 meters. If you compare the top portion of the screen, this is a prediction for the ground path distance between two stations, 250 kilometers. Frequency is 3.5 megahertz. Can you see this? Or something?
Yeah.
Right. And it says here that if you run 100 watts into 100% efficient antenna, which is possible, overall loss from transmitter to receiver is 148 decibel. 148 decibel is a loss over 250 kilometers on a ground wave, 80 meters. You run same figures for 475 kilohertz, 630 meters, you will notice that overall loss is only 100 decibel, 100.5. So a signal, 5S unit signal in Canberra on 80 meters will be S9 plus 20 on 630. You can run these numbers and there are reasons why. I'm not going to go into with this, but this is fantastic. We just got, by moving from 40 meters, from 80 meters to 630, we gain how many decibels? 40 dB, 48 dB. Fantastic. Free. Another beauty of this is antenna efficiency that we run this still is only 5%. So if you have 5% efficient antenna, only 5% efficient antenna, you still have almost 50 dB advantage on ground wave propagation. So it is a magic. It's really, you know, 3 decibels. Next one, please. So what kind of equipment we use on 630 meters? Well, you have to have some kind of receiving antenna, and you have to have some kind of transmitting antenna. Ideally, you want to have separate receiving and separate transmitting antenna. Not always possible on a block. Some kind of receiver or transceiver, some kind of transmitter, and you need your PC plus various signal decoding softwares. There is unfortunately not much that is ready to be used or plug in and play for 630 meters, which is great news for home growers. Next one, please. Receiving antenna, everything which works already invented. We're not first users on a band. For years, for 100 years, people using, you know, a commercial broadcasters, they've been on medium frequency. So we know what works, we know what doesn't work. Of course, the best antenna is beverage, unfortunately out of question. You can't put a beverage antenna on your city block. But you can put up antenna of this size. I know some of you know what this is, right? Okay, it's a little E-field probe. It's called Mini-Whip. It's an active antenna. So there is a, active part is this, and the active part is this. You attach this on a pole. It has to be half meters to a meter above anything else, above your rooftop. And this is fantastic receiving antenna for 630 meters and lower. Again, you can look it up. Most of the stuff that we've been talking tonight about was received using this. Right? And you can put it up, no one can see it, and you will have a lot of fun. There's some other antennas. Please, next one. There's some other antennas also. Tim, can you please help us here?
Transmitting antenna. Vertical polarization is subject to considerably less attenuation than horizontally polarized signals. In some cases, the difference can amount to several tens of decibels. That's significant. It is for this reason that medium wave broadcast stations use vertical antennas, even if they have to be made physically short by adding inductive loading.
Okay, so vertical, no horizontal. You can, that apply to medium frequency, but also you can notice that on 160, and you can even notice that on 80 meters. I'm fairly active on 80 meters now, and I've got a lot of emails from people saying, oh, you're loud, I can hear you, but you can't hear me. And in 10 out of 10 cases, it's only one thing. They have horizontal antenna. Put up a short vertical, I will hear you. It's simple as that. It is, the higher you go, it's not a big deal, but the lower you go, it is. So don't try to stretch. People try full-size dipoles, full-size loops, and all sorts of things. 630 meters doesn't work. It's vertical that you want. Next one, please. So this is typical 630 meters antenna. I said we don't have to invent anything. We just have to copy what the other people do. This is a typical non-directional beacon, avio beacon transmitter. That little hub there, and antenna is a few wires. It could be one wire. It could be one horizontal wire, which is just a capacity hat on top. And this basically what radiates is this. Yeah? So that's what radiates. Relatively short. How tall is this? Probably, I don't know, 15 meters, 20 meters, and that works fairly well. So if you want to learn what works well, just go and see what non-directional beacons people do and use on medium frequency. Next one.
So what it says up there, PD230.
This is Oregon beacon which transmits on 230 kilohertz, and that's his antenna. They're probably running anything between 25, 50 watts, 100 watts, and there's some powerful non-directional beacons which run, a kilowatt. You have Richmond runs kilowatt.
So this was an aircraft beacon, was it?
It's aircraft beacon,
Oh,
yes. There is a slide that will explain, you know, the band is covered with those signals. If you tune from 195 kilohertz to about 480, you'll find a lot of signals. Actually, I spent 2 seasons doing nothing, just tuning into non-directional beacons, and I was able to log about 320. Some far away. There is a group of amateur radio operators who spend their entire life just chasing non-directional beacons. The highest score in Europe is 2,300. In US it's a little bit less, but yeah, there's plenty of those beacons. Next slide, please. How to build. This is a quick guide how to build, and I'm not going to go in details. I'll skip most of the stuff. How to build transmitting antenna. So receiving antenna is easy. Transmitting antenna is a problem, all right? Because you need. Next one, please. Tim, can you just read from here to there? Thank you.
A word of warning. Erecting a tall structure in an urban backyard will inevitably have visual and social impact. In most cases, such impact is negative, and it's That's very true. Be aware that your neighbours and family members will most likely express their disapproval. It is therefore important that you do your best to avoid any conduct which will further antagonise your loved ones. Stay focused, well organised, and keep the backyard and lawn clean.
Is that from experience?
That's from experience. It took us 6 months to get it right. So I'm going to save you time. If you're crazy enough to try this, it really comes down to doing it quickly, doing it once. You don't have to take your antenna 50 times. And understanding the steps. Please, next one. So the few components of your transmitting system that you have to get right. If you fail on one, you will not be able to transmit. Right? Everything is equally important. Feed line is the easiest thing. It's just your coax. Ground system. More radials you can put on the ground, better. You don't have to go crazy in the length. If you can only stretch 10 meters of wire, if it has to go zigzag, that's fine. But put as many as you can. Your radiating structure. See, I'm not talking here about the antenna itself. I'm talking about radiating structure. We'll talk about this a little bit later. You need the loading coil because your antenna is. Just think of it of a short mobile antenna on 40 meters. That's what you're basically trying to construct. Yeah? Short antenna with a huge loading coil on the bottom. You need a tuning unit to make antenna resonate at certain frequency, right in the band. And you need to match impedance because it's never 50 ohm. And it's not easy to calculate what your antenna system will have impedance. So it could be more, it could be less. Next one, please. We'll skip this. Next one. Ground system again. More the better.
Okay.
This is the important one. Radiating structure. I've tried and others tried to put up a mast like this, aluminium mast, and then use this as your antenna. The problem with this is you have to guy wire it, and you have to somehow support it. So unless you have excellent porcelain ceramic insulator, you will have a lot of trouble. If it's rain, if it's humid, it will change. There's a lot of voltage in this antenna, short whip, and all your PVC stuff will just burn, right? It will burn invisible holes, and you will look at your antenna, and it won't be resonant, and you will not be able to figure out what's wrong, because if you have any PVC, so what you really need is something to support. This is just to support your wire, and that wire, I choose 21 meter because it resonates on 80 meters as well. It could be shorter, it could be longer, but you want that wire to be free of any contact with anything else, right? And I'm talking like distance like that. All right. So if you get this right, that is a key. I have to again say, I've seen people struggling for months to get their antenna to resonate, and it works today. Next day it doesn't work because of things burning. Next one, please. The next one, please. Loading coil. Well, you need about 600 microhenries to resonate 20 meters long piece of wire on 630 meters. So it's simple. A bucket. I use yellow-green earth wire. That's fine. You need about 60 turns. Not critical. Next one, please. You skip one back, please.
Back?
Yeah. Variometer. These things tune your antenna, so you need to add a little bit of more inductivity or less. You know, this is like 2 coils. You turn one. You know what it is. I don't have to explain this. It's simple. You know, you have 2 coils working together. As you physically, you know, shift this one inside the large coil, you change the total inductance of the of your system. So you need a mean of changing the inductance. People try tapping large coils. It doesn't work, right? Because it's very difficult to tap thick wire and to find a spot where it works. You know, it's really difficult. So this is simple and elegant homebrew solution. Next one, please. This is impedance matching. I don't have it here. Simple transformer. My antenna is around. My antenna is very close to 50 ohm. So I can almost get away without it. But the reason why I really wanted around 30 or 20. That means I have low losses. High impedance means I have a lot of losses because everything sucks energy that is the trees and shrubs, and I'm also on the sandstone, so my ground system is poor. But you definitely need one of these. That is half an hour job if you have the right core, easy to make. Next one, please. So this is how it looks like. So you got your radials, impedance matching unit, loading coil, variometer, and then antenna wire. Important thing also with wire is if you can go, let's say 15 meters vertical, and you want to add as much wire on top as you can, make sure that additional top loading wire goes horizontal, right? If your wire is sloping down, you're actually reducing the height of your vertical section. So there is no point of going 20 meters high and then going down to, you know, and you effectively have only 10 meters because current wants to go there, and you need that horizontal. That's very, you know, again, you who know what I'm talking about understand this, but again, it's better not to have top loading wire. The longer wire here, the less inductance required. That means less loss in your system. Ideally, you want, if you can run 20 meters in this direction, 20 meters in this direction, you will reduce this from 600 microhenries to maybe 400. That's a good thing. Okay, next one, please. I'm not going to spend any time on this, but receivers, some work, others don't. Not all ham radio receivers are designed and engineered and made for medium frequency. Right? There are some receivers which are marine grade and IC7200, for example. R75 people still use this stuff. That's good receiving. But there's a lot of homemade software-defined radio stuff. And then if you want to spend a lot of money, you can go to a box like this. A lot of money. You've seen this. This is the Italian software-defined radio receiver. Virtually 0 to 40 megahertz. And it's this box allows you to see all the signals that we're talking about. It's about $1,200 and excellent resale value. If you ever want to sell it, there's always someone out there who will buy it. Next one, please. Yeah, this is non-directional beacon spectrum. See, when I plug this piece of antenna into this radio and into my PC, this is what I see. Right? And for example, these are carriers, right? And these are signals. So this one is SGT, that's singleton, right? And as next, another one would be NAR, narrow, right? And so on and so on and so on. This one is Richmond, so it's a voice as well as the CW. So if you tune on 348, you will hear it. We can tune it now. We will surely hear it with any antenna. So this is your neighborhood. These are your guys. They're just slightly below us. Right, next one, please. Transmitting, again, homemade. CW is easy. It's very easy to get on band with CW, but CW is not everyone uses CW, so you won't find a lot of people interested in making two-way CW contacts. Next one. Amplifiers, it is easy. E-class, 100 watts you can get from one MOSFET. It's literally a 5 components amplifier. 100 watts is not a problem. You can run 500 watts. You see, 500 watts in 1% efficient antenna, this is your 5 watts output that you're allowed to run. So you can run 500 watts into any antenna. You will never go above your 500 watts. You need to have a low pass filter as well. This is the homemade one. It's easy again to make, no big deal. Next, please. So what do amateur radio operators do on 630 meters? Next one, please. Okay, you all heard of whisper, right? So people do whisper on 80 meters. Basically, there's a piece of software like A1JT. You plug this your sound card output into your radio input, and signal is transmitted. You transmit at low power, and then you just watch to see who copy your signal. Whisper can decode signals up to -28 dB SNR. So yeah, few watts. This is typical. Well, I wouldn't say typical. This is busy night on 630 meters. You see, there's a bit of activity in Adelaide. There are a couple of guys. This guy is fantastic. He lives in a rural area. He can hear everything. We get activity around Brisbane. We have a couple of guys in Tasmania. There's a little bit of activity. There's a fair bit of activity in Sydney. VK5ABN in Northern Territory, and we struggle with VK6 because there's just no one there. Next one, please. And this is, when you look on the other side, the 3 or 4 New Zealanders who are basically fairly active. They have proper setups, and they can be easily decoded in Sydney. So this is a night where I was heard by all those stations. Yeah, so you plug your setup, you can go and watch TV, you come back 2 hours later and you see who decoded your signal. Next one, please. You've seen this, next one, please. PSK31, in another typical HF mode. This is a test signal transmitted with PSK31. It works, it's not the best, but it works. So, this is signal close to VK1DSH is very active. He was transmitting and I was receiving this. You can see it, perfect copy. Next one, please. I'll skip this. Next one. That's a fun mode. This mode is designed for low SNR, MFSK15. This is VK2DX to a shortwave listener or medium frequency listener in Tasmania. His name is Edgar. He's fantastic. This guy is priceless for our group. He's not a ham radio operator, but he knows all this stuff. And he spends a lot of time and he enjoys it. He's not licensed. He's fantastic. He's not transmitting, he's receiving. You see, perfect copy. That's 1,040 kilometers. Every single, and I was transmitting 100 watts output into that antenna user. So it's possible, it's fun. You can make a good contact of 1,000 kilometers easily with MFSK. Next one, please. Next one. JT65HF. This is what people use on 2 meters EME. So it is, you can receive signals up to probably -25. Easy. It's slow. It's not designed for fast exchange. So you basically enter your call sign, name, and you press buttons in certain order. Yeah, signal is decoded automatically, recorded the -13, -11. So, yeah, next one, please. But that's exactly what people do in 2 meter EME. So you can do this on MF on 630. Next one, please. The people out there who do not transmit, but they have what's called the grabber operators. So they have their setups where they have receivers and computers running 24/7, and then images of what's decoded or what's transmitted is uploaded online. Right? So if I'm transmitting, this is automatically refreshed maybe every minute or 2 minutes. So if I want to see how my signal is on someone else's grabber, I transmit I log into go to web page, and then I can see my signal. All right, so there's no need to have physically another human on the other end to see what's going on. So you can see 2 signals. That's one. There's another one there. Next one, please. This is MFSK 16 signal on a grabber, so it doesn't look as pretty as the other one looks like, but that's a signal. You can see where it started and it stopped, and it's much wider signal. Next one, please. Okay. People try also silly things, and they have a lot of fun doing really silly stuff. This is a signal received over a distance of 112 kilometers, and it's just 5 volt peak to peak. It's about 60 milliwatts into 50 ohm, which is about 3 milliwatt radiated power received over the distance of 112 kilometers. And that's what it is. It's a little DDS VO4 that you can buy on eBay for, I don't know, $30. So it's very stable. It's fun. If you can find a way of, and people spend hours trying to modulate this signal and do all sorts of things. So it doesn't matter. It can be. This is your 48 dB on 630 versus 80 meters that we talked about. Next one, please. What is this? Again, JT65. Next one. Okay, so activity. This, after about 3 months, see that was, last entry was on 16th of March 2013. We got a band on 1st of January. So after nearly 3.5 months, I was heard by 27 different stations in Australia and New Zealand. So you keep record of this. So 630 meters is a good band if you have nothing else to do. And you like keeping record and all this stuff, so collecting data, so it's fun. So VK2AWD, gentleman is in, I think, St Ives. CCJ is south of Sydney. OF is the guy in a rural area. ZL1, VK5ADM, so next one, please. Yeah, sometimes we do have VK6 tuning in. That's often by mistake, because WISP records and they're really on some other band. So we get really excited. You're sitting there for 2-3 hours and you see someone in VK6 is on 630, and then you realize, well, he's there by mistake. So, but that's your core activity. Next one, please. Records. Well, on top of the record list is ZL1QM, who made it to Northern Territory, and there was 4,157K on a Whisper. And that's not bad. 4,000 kilometers received, covering the distance of 4,000 k. I'm sitting here. I just passed 3,000 k. That was a big milestone for me. I got VK6XD. These guys just passed 1,000 k barrier. So, what is the fun? Fun is to set up your antenna system and then spend as much time on air waiting for good opening, waiting for low atmospheric noise night where your signal will travel, and then you wake up in the morning, you see data, and then you made it to New Zealand. It's a big thing. People that get really excited when they make from East Coast to New Zealand. But your goal is really to break next 1,000 k barrier. So these guys are working really hard to get to 2,000. As I said, I'm here. I just barely made over 3, and so on. Next one, please. So the question is DXing possible? So we can do a few hundred kilometers, 1,000 kilometers, 2,000-3,000 kilometers, almost every night. But is DX really possible on 630 meters? Okay, we have to watch against signals in our neighborhood. This is 518 kilohertz signal. 518 kilohertz signal. Call sign is NMC. NMC is, Brent, you should know this. Where's Brent? Fawcett. What?
Come on.
US, it's American signal, yeah, somewhere in the US, starts with N. And you can see here, you can read ZC. You guys know what ZC is? Teletype guys? Yeah, it's your message, start a message header, California entrance to San Francisco Bay, Golden Gate Bridge, there's one missing. But it's almost 100% copy. Okay, so this is NavTex signal. It's really your RTTY. It is the RTTY finally. So it's 518 kilohertz. Problem with these guys is they only transmit at certain time. So they go on air, they send that message, and they're silent for another shift of 4 hours. So if you to tune in to this frequency, expecting to hear that signal, you have to know when is transmitting time, because most likely those vertical lines are discharges. This is your QRM, static crashes and so on. But these 2 traces, that's a signal, right? And this is what you see is what is decoded there. So next one, please. NMC is US Coast Guard station located somewhere here in California. And this is their intended coverage, right? So that's where they expect to be covered. Hawaii and Japan here. Next one, please. And this is NMC decoded perfectly on 518 kilohertz. That's just slightly above us. Distance almost 12,000 kilometers. So their coverage area is here, but we got it. Highly propagational, highly seasonal. That means this is only possible in September, for a few days in September. Next one, please. Well, you can say, okay, NavTex on 518 kilohertz decoded, but these guys run serious power and they have good antennas. And it is true, they run a few kilowatts and directional antenna as well. But what about stations running small power? Well, this is a 300 kilohertz Hawaiian station running 100 watts differential global positioning system or DGPS transmitter, decoded perfectly in Sydney using this. All right, so this is 8,000 kilometers, 100 watts possible. No problem. Good copy, good decode. If there was a hand radio operator on the side running 100 watts, you will have a proper contact. Next one, please. This is another. This is my favorite. 138, 39 kilohertz. So we are going really down, sort of bottom end of medium frequency. This is a signal just above noise. What you see is a really a carrier. And then every now and then it just goes, and then it's carried. Well, that perp bit contains data, right? It's data part of the signal, and it was decoded as a DCF39, so burn DC,
Delta Charlie?
yeah, it's a
German.
telegram number 15, 1st of September 2011, time, summertime, so all that in just one burst, right? Decoded perfectly using this antenna on 139 kilohertz.
But what is it? Who is transmitting it?
It's a data signal to control power grid in Germany.
Yeah, DCF is the clock signal as well.
This is not DCF 77.5 is a
Yeah,
time
the clock
signal, so it's further down on the VLF. Also decoded and received in Sydney, and actually I have a QSL card. When I emailed them, this is not long ago, I sent an email after I decoded time signal, and they sent an email, engineer from DCF, it's institute, technical institute. He said this is not possible. We have IRU charts which tells us that the maximum coverage is 7,000 kilometers, so you're cheating. And I explained to them, well, that's a ground wave. But your signal is actually bouncing off something that is ionosphere, and it is decodable here. And they really got excited. I got a QSL card confirmation for that. And this gentleman in Tasmania as well. There is so much going on all the time. If you only tune to 40 meters sideband or 20 meters CW, you're really missing a lot of action. Next one, please. Now, this is a good one. VK1 DSH, that's a gentleman in Canberra, decoded by VK5 APN, -13, decoded by, in Brisbane, decoded by his local guy, and decoded by F6CNI/BEV in France. This is Whisper 630 meters. Fantastic. So it is possible. Now, this guy was not using this antenna, a Frenchman who decoded our guy in Canberra. He had a proper beverage, long beverage antenna, and he explained what happened is he was in his car and he parked near the golf course one night and stretched the antenna, hoping to decode some signals, and he was in shock when he received a signal in Australia, from Australia. It has not been repeated since, right? We spent a lot of time trying to stretch that far away, but it has not been repeated. That means it's propagational. I think it will happen. Next one, please. Get involved. All right. You get your receiver tuned down. If you have, if you like to set up a grubber, you will provide a very valuable service to fellow enthusiasts. You can try to set a new Whisper record. And we have a really good reflector, which is fantastic. We have about 70 or 80 people there, very friendly. We talk 630 meters all the time. Some of the smartest guys ever. I'm just, most of the stuff just, I don't get it. But last week, a gentleman in New Zealand came up with a mode. Which is basically a Whisper. Decoding level, but two-way. So you can actually have a real-time QSO at a signal level of -28, 29. This is kind of as low as you can go. Plus, it was specifically designed for 630 meters, taking into account everything else, uniqueness of the band. So it's really cutting edge of ham radio. That was just released last week. Next one, please. I think that's the end. Yeah, our group is 600 meters. It's not 630, it's 600 because we used to be a little bit higher on band, but the allocation is 479. Thank you very much for your patience.
A couple of questions. Maybe you could explain about why the ACMA are so insistent that you have a low EIRP and also the low pass filter, because that's critical.
you don't want to cause interference, okay? Because people will do all sorts of things to cover distance, right? So let's say you are in rural location, you have your 40-50 meters tower, and some people do have 40-50 meters towers. You can easily build this A-class amplifier, a couple of kilowatts, and you will exceed, limit, and you will cause problem to other users on a band. We're not only users of the band. There is actually a non-directional beacon on 400, just a couple of about 5 kilohertz above the edge. All right, so but also there is exclusion zone in Northern Territory. Apparently, explanation for low power, and that's right. If you're VK8, you cannot transmit at all. So there's exclusion zone to transmit because apparently we could interfere with a setup, military setup in VK8, Darwin area, and Dili. Whether that is an excuse or not, or real or not, I don't know. But that's explanation. Is that what you were referring to?
I was just going to say the third harmonic falls in the broadcast band. That's the killer.
Yeah.
That's the killer deal. And in terms of harmonisation across different countries, how many countries have access to the same slice?
Yeah, well, we are all on the same slice now.
Every country.
Before, it's still not in US. US are not allowed to get on. They still have their own allocation, slightly higher. But all Europeans and most other countries,
Okay. Well, that makes sense.
Japanese are still not allowed to get on. It will be a big thing. This is when we're going to break, 4, 5, 6,000 kilometers barrier once they get on here, because it's a north-south path. It's fantastic. So Russians are not allowed at all because their non-directional beacons start at 160 kilohertz and they go all the way through the MF band to about 1.4 megahertz. Because East Russia, all they're all about 700, 800, 900. So they don't want ham radios operators at all on medium frequency.
Yeah, there's a whole bunch of countries where it's not allowed. All of those countries, all the stands and all the northern African countries. I think, it's sort of when I visualize the list, it's the big list.
But the allocation is there. It's just a matter of national, organizations to allow locals to get on there. I just showed this. This is something I was involved with. This is a software-defined radio transceiver. It's 10 watts. It's a kit, so most of the SMD stuff comes pre-soldered, and then you install larger components. I have to say I'm very proud that I was part of this, not on engineering side, of course, but I was a stupid one that put my money into it as an investor. But we sold it out completely. We sold 400 units all over the world, only maybe 3 in Australia. But it was big in US, big in Europe, big in Japan. We have no more to sell, so I can now say that I was part of this. It's fantastic. I can leave this on and whisper for days. It wouldn't move. It wouldn't, and it gives you all modes. So having ability to have all modes on 630 meters is tricky. You will find once you start building stuff, you'll realize it's not that easy. This is a Tim, you've seen this one. You helped me with testing this. This is the first transmitter. This is CW only. It can run as a beacon. It's a Finnish. It's called Yuma. 60 watts output.